In this video, we are going to do some basic probability. And we are going to use a deck of cards. So hopefully you are familiar with the deck of cards. So just real quick on that, we have 4 suits. We have hearts, clubs, diamonds, and spades. And each suit has numbers 2 through ace. I usually think of ace as being the high card. So remember, jacks, queens, and kings are known as face cards. I think that's about the basics. That's what you need to know in order to get through these. So that's for every suit. So there are 4 jacks, 4 tens, 4 eights in the entire deck of cards. 52 cards total because there are 13 of each suit. Okay, so the first question we're going to jump into, what is the probability of choosing a 10 and then choosing a 4 without replacement? So we're choosing back-to-back cards, and the big key here is without replacement. So that means our first card we're choosing a 10. And if you recall, there are 4 tens, 1 of each suit. So that would be 4 out of 52. Because out of 52 cards, I have 4 chances of picking a 10. Now, we're and means to multiply, so we're going to multiply, and then we're going to choose a 4. Well, there are 4 4s as well, but the key is without replacement, meaning after I took that first card, I did not put it back in the deck. So instead of having 51 cards, or 52 cards to choose from, I now only have 51 cards to choose from. So you can see how this kind of changes our multiplication piece. Now, if you wanted to, you could reduce this fraction to 1 over 13 times 4 over 51. It gives us a fraction of 4 over 663, which as a decimal is 6 thousandths. So that is the probability of choosing a 10 and then choosing a 4 without replacement. What about the probability of choosing a heart and then choosing a jack with replacement? So now we're going to put it back in. So the first thing we're going to do is we're going to choose a heart. And remember, hearts are one of the 4 suits. So we have a 1 in 4 chance of picking out of heart because there are 4 suits and hearts are one of them. So then we put it back in, right? Because that's with replacement. So we take out a heart, we put it back in. Then we want to choose a jack. Well, a jack, there are 4 of them out of 52 cards. And again, remember, it's 52 because we put that first card back in. Well, we can reduce fractions. So this is the same as 1 over 52, which as a decimal is 19 thousandths. What about the probability of choosing an ace of spades and then a jack of hearts without replacement? So the ace of spades, there's only 1 ace of spades out of the 52 cards. And then the jack of hearts, there's 1 of them. Remember, without replacement. That means I took that ace of spades out and I did not put it back in. So I'm down to 51 cards. Therefore, my multiplication yields 1 over 2,652, or as a decimal, we're at 4 10,000ths. So a very small probability of you being able to choose an ace of spades and then a jack of hearts without replacement. Last one, what's the probability of choosing 5 consecutive clubs without replacement? So let's say you're playing poker and you want to flush, right? Now, we are not counting into effect anybody else. We're just talking about your cards, 5 consecutive clubs. So think about this first. The first card that you deal, right, the probability of you receiving a club is 1 out of 4. All right, so that's your first card because there are clubs as one of the suits. Now, without replacement. So now you've taken out a card. You've taken out a club. So now you have 12 clubs left out of 51 cards. Because remember, initially there are 13 clubs out of 51 total. Oops, out of 51 total. All right, so we have our 1/4 because clubs are 1/4 of the cards. Our second card, there's only 12 clubs left out of 51. So you can imagine our third card, well, now we're down to 11 clubs out of 50. Our fourth card, we're down to 10 clubs out of 49. And then we're down to 9 out of 48. And if you're using a calculator, you might say, oh, this is great, just plug it all in. But let's just practice a little bit of reducing. I mean, 10 goes into 50 5 times. 4 goes into 12 3 times. 3 goes into 51 17 times. 9 and 48 are both reducible by 3. Is that it? I think so. So if I rewrite my problem, this is just a 1. Then I have 3 over 17, 11 over 5, 1 over 49, 3 over 16. And you might say, Becky, that was dumb. And that's fine, you can think that. But I do like to practice my reducing skills. So we end up with this. When I multiply, I get 33 over 66,640, which is roughly 5/10,000. Oh, that's not good. There we go. So that is the probability of you taking a deck of cards and just dealing out 5 consecutive clubs without replacement, right? So after the first card is out, it's done. You can't get it again. And that's your basics of probability with a deck of cards.